Hello, everyone, and welcome. It is Wednesday, the 1st of June, 2022. We are gathered here for the 107th consecutive Knowledge Bolide Hangout, sponsored by Topherspin Meteorites. Today, we're going to be discussing chondrites, and they're a lot of times called ordinary chondrites, but we're going to be discussing in our 101 with Mike Kelly, you're not so ordinary chondrites. So stay tuned for some education on the Meteorite 101 segment and a lot of quality show and tell of meteorites throughout the day. We are going to jump into some late and breaking news concerning one of our Knowledge Bolide Hangout members. As I said, it is our 107th in a row, and the news we have is about our very own Chris Monk, the Monk Man. Congratulations, Chris Monk, on getting in the Met Bowl for the first time, ×2.
Yay!
All right.
Congrats. And the crowd goes wild.
And consecutive numbers too.
Congratulations.
Yeah, sexy.
I haven't seen that before. That's when you get super lucky and you send in 2 samples and they're dealt with at the same exact time. Is that what happened on this one, Chris?
Yeah, so I sent these both in at the same time, and he did all the work on them, and then they were submitted at the exact same time to the NomCom. So I ended up getting consecutive numbers.
That's really cool.
That is really neat. Yes. I have another question about, because originally, if I remember correctly, you thought the material might be the same material, but when you actually got it in your hands from Africa, it was dark material and lighter material. So have you seen any differences? Have you looked into the Met Bowl science yet to see what, if any, differences chemically there was?
I haven't like listed them out next to each other where I'm comparing this element to this element. The biggest ones that you can notice is the metal content in 14837 is higher. I don't know if that's the color difference reason. So one of them is a much darker brown, and the 14838 is almost like a milk chocolate brown.
Very interesting. Well, I'm glad I asked, because I forgot that one was more attracted to a magnet. And so thanks for joining us from your busy work site today, man.
No problem.
Yeah, really congratulations on being in a Met Bowl. I know that you've wanted that for a long time, and I know that's just the beginning. That's the tip of the iceberg of classifications for this guy.
Oh yeah, there's
Very
a bunch
cool.
more in the works.
Do you know how many there are right now submitted?
So he's supposed to be submitting 7 more in like 2 weeks.
Wow.
Oh, wow.
You're gonna keep
be
Sue
all over the
busy.
Met Bowl soon.
What's that?
You'll be all over the Met Bowl soon.
Yeah, you get monked. Well, we're going to move on with a little bit of show and tell right now with Cliff. So Cliff, if you can unmute yourself and tell us what we are looking at and why we should care.
Well, I can do part of it at least. What you're looking at is Los Vientos 295 oriented L6 chondrite from the Atacama Desert. This was one of the earlier meteorites I got, actually, and it's struck me when I was looking at the original listings just how clear the orientation was on this specimen. And I'm glad you let off with the in situ photo, because you'll now know why the bottom is cut off. Normally, I'm not an advocate for cutting oriented meteorites, but in this case, nature took care of it for us. Yeah. So the this is the main mass, actually. So there's the classification specimen in this. It's fairly weathered. I would love to know, and I don't know how you would tell at this juncture, but I'd love to know if the front of that, face planted and broke when it landed, or if that was the weathering that broke it off, because it looks for all the world like it just plowed into the ground and broke off on the nose. And you can, unfortunately, this one doesn't have a really clear rollover lip. It is thicker on the back, And that label is from the original finder. That's not my label. You can see this is one of those classic Atacama weathering patterns where it's got to be an old meteorite, but the fusion crust is still present on the stone, despite having cracked almost all the way through. And I don't know of anywhere else in the world where you tend to see those kind of weathering patterns. Normally, if it's been on the ground long enough to crack like that anywhere else, the fusion crust is pretty much toast.
Yeah, the Atacama meteorites are very different, and the terrestrial ages of them are extremely high. Many, well, I don't know about many, some of them over 1 million years, but this is the driest place on the planet. So
if you compare this to Australia, they're quite different in way, really.
So there are, it doesn't unfortunately show in this video terribly well. There is a little bit of metal that is present in the cut face, so you can see it. But as an L6, this won't show too many chondrules. This is largely homogenized. The showcase feature there for me is, you can kind of see it on the right on the screen here, the regmaglyphs that were carved out. Yeah, right in there. That's
let
the
me move this. Yeah, that is gorgeous.
Almost looks
right
like
there.
fluting or something. Yeah,
it is a little bit. Yeah,
They're very obvious. Yes.
Aligned regmaglyphs, so it shows an organized flow of, and those ablation features are parallel, so it shows organized flow there, and that's orientation.
And it's in person you can see that it's pretty subtle, obviously, because of the weathering, but there are still flow lines present on the front of the stone. And it I couldn't, this is one of the earlier ones I got, and it's, for me, it's a pretty large meteorite, but I just couldn't pass it up. It was just so clear, so excellent in its features. And it's, it is a weathered L6, but it's a main mass, it's an oriented stone, it has fusion crust, and it has an in situ photo with fine coordinates I got it from the original finder. So
very cool.
There isn't a lot not to like here.
I just read that the Atacama gets less than 1 millimeter of rainfall per year, or precipitation, and that there's some parts of the Atacama desert that haven't seen any rain in almost 500 years. Isn't that crazy?
Wow.
So that's where you want to go.
It's kind of like living in Buckeye.
So this may show the flow lines. I tried to side light it here. I don't know if it, there it goes. Yeah. So as it comes around to the front, if you look, you can kind of see it streaking there.
Oh yeah, you can see them.
Wow.
Yeah.
They're pretty obvious, really.
Yeah, no imagination needed.
No.
Oh.
They may be weathered.
Oh, you dog. You dog.
Yeah.
Maybe weathered, but they're still pretty.
Yep.
Yeah, that's beautiful right there, man.
Really sweet there, yeah.
And it should show on the other side too, but yeah, that's the most spectacular there.
Right.
Yeah, very cool.
Yeah, that's highly oriented now. Look at that.
Yeah.
Radial lines going over the entire crest of it.
So I figure that's probably the only one Marco missed.
Nice.
Totally obvious. Yeah.
Was that your first main mass that you purchased?
Yes, actually, it was.
That's awesome.
Cliff, thank you so much for sharing that beautiful oriented meteorite with us. Really appreciate it. And that is an L chondrite. So
L6.
All right,
So
thank you, man.
That's how you make the ordinary extraordinary.
Yeah, add some orientation and flow lines and a nice backstory with an in situ picture. Fantastic.
Beautiful, beautiful.
Last week, we did a non-recorded hangout where we got to know each other a little better. We actually did show and tell, but one of the rules was it cannot be meteorite related. So, Cliff, did you show something last week in the show and tell?
I did. Semi-space related, actually, is one of the original NASA special publications from 1960s having to do with rocket propulsion. Every once in a while, you see some of those floating around online, and I happen to get lucky. So
awesome.
Yeah.
All right, thank you. Yeah, I'm going to ask everyone when you start your show and tell today, if you can just tell real briefly what you showed last week, because we had a lot of really varied items and some really interesting talents and skill sets within the crew. So it was a great hangout. So Pat, I'm throwing it over to you, buddy.
Okay, very good. So last week I showed a bunch of radioactive stuff. Meteoritics is my main hobby, but I also enjoy ionized radiation measurement and such. So I showed off a bunch of odd radioactive stuff.
Cool, thank you.
And then on chondrites, one way that ordinary chondrites are not actually quite so ordinary is in the very, very primitive ones. This one is an LL3.00. There's extremely little of this material on our planet, but this is basically ordinary chondrites without any amount of metamorphosis from heat and pressure, accumulated time under heat and pressure. So this is what ordinary chondrites all started out to look like. Here's another one that is an LL3.00, and there's literally a few kilograms of this stuff on the planet. Most of our ordinary chondrites have experienced more metamorphosis. Here's a very colorful 3.05.
3.0. That is gorgeous, man.
That's artwork right there.
That's so colorful.
Party lights.
Funny because the color comes from the trololite corroding and staining the chondrules all these wonderful yellow and orange sort of colors. So it's interesting in that the colorful part of it comes from the terrestrialization of the rock. And then this is one that is not classified yet. This is hopefully an LL3 low subtype ordinary chondrite. And this one shows off a nice carbonation as well.
Looks like a CV3.
I was going to say, it looks like CM.
So, ordinary chondrite is kind of a self-deprecating term. The one thing that's important, I think, to take away from the scientific part of this is that the chondrules, the little individual balls of silicate material there, allowed scientists right at the end of the 1700s, beginning of the 1800s, to see that these special rocks that they found were out of context with the local rocks, but they were in context with each other. So we started finding these ordinary chondrite meteorites around the world. And one of the things that allowed us to let ourselves think that they're not terrestrial material was that they're all over the place on Earth, but yet they look the same.
Ooh, that's an awesome thought.
Wow, that is gorgeous. And these are all LLs or Ls?
These are all LLs.
Nice. But I wanted to get into a little bit of science behind chondrites. So when we get into, in a few minutes, the 101 session with Mike, we can understand it a little bit better from a YouTube point of view. When there are the meteorites that fall on Earth that are collected, the vast majority of them are ordinary chondrites, the stuff that you were just looking at. They're H class, L class, and LL class. And those three classifications encompass the vast majority of the meteorites that fall on Earth. So that's why it's kind of important we do a show to understand these three classes a little bit better. We had a little homework assignment to talk about the actual metal content because that's the differentiator in a lot of these classes, is the amount of total metal and free metal. So who knows here the metal content in LLs and H's? A little help?
I've got it.
Okay, awesome.
So in LLs, metal is roughly 2% by volume. In L's, it's roughly 3% by volume. And in H's, it's roughly 8% by volume. Now, those are an average sort of number, and we actually see quite a range of metal content in the various meteorites, particularly in the H's. And there even are some very, very special H's, and maybe Topher will show one of his later, that have huge amounts of metal. Average of 8%, but there are many that are in, well, I shouldn't say many. There are some that are 30% or even higher, and some very off the extreme end of that. Now, there's also troilite common in these ordinary chondrites, and in the LLs, it's about 5% by volume, L's about 7% by volume, and H's again about 7% by volume. And of course, troilite is FeS, iron sulfide.
Mhm. Thank you, Pat. So that's one thing that we do is with our magnets, we do our magnet test, and we can tap on a rock and usually get a good estimation for ourselves of where the metal content comes in, and giving a class of L, LL, or H. When you look at the ones that Pat was just showing, you don't see really any metal in them. You know that they're going to be LLs. I'm going to show you, as Pat kind of teased, I love H's. So a lot of people get into the chondrals and they're like, oh my God, these chondrals are beautiful. And yeah, they are. But man, you're missing the metal. Check these out. Check these out.
Oh yeah.
Which
So
one is that?
You're not seeing a bunch of chondrals in there. This is classified as an H4. So there will be chondrals in there, as you see over there.
Yep.
But the catch is the metal.
Which meteorite is that?
This one doesn't exist. No, this is Nova 009.
Ah,
Yeah, so unfortunately, sometimes like when we know where it comes from, it gets the nomenclature of NWA, Northwest Africa.
right.
Sometimes when there's not enough documentation to prove where it came from, it's given the Nova nomenclature. So this is Nova 009 in H4 with loads of metal in it.
It's impressive.
Yeah, I love this. I love this one. Another thing that you'll see in H's that you won't see in L's.
Oh,
Oh
yes.
yeah.
Circles.
Wow, you can see the
Three-
texture on those on the exterior.
I know.
Oh.
It's wild. You can you can literally see the brain-like texture on those things, and my heartbeat.
Huge.
And that one is 14488, Topher, your
Yeah.
impact melt.
You are correct.
Oh.
And now this is a very special meteorite too. The metal in ordinary chondrites is not normally in pretty spherical little balls like that with a mixture of troilite and iron. This is a meteorite that suffered an impact that was large enough and energetic enough to actually melt parts of the rock. And you can see in the upper right the speckled iron, and that's what we would more normally see in an ordinary chondrite. But in the melted parts, this was melted enough that the iron was able to get together in these spheres and cool fairly quickly. And so there's nothing ordinary about this ordinary chondrite.
The round metal looks an awful lot like Gujba.
Yeah. I wish I could sell this for Gujba prices.
Yeah.
Okay, so that's a beautiful example, visual example of why, hey, just don't discount the H's, folks. There's a lot of beauty in a meteorite, especially when it has that much heavy metal in there. So
Very
yeah,
cool.
crash on. Let's see what Allison has to show. She has her hand up for us.
Well, my samples are pretty small, but on the left, I have an LL5-6 chondrite, and it is NWA 7538. And on the right, I have NWA 14007, and it's an LL3 7538.
7538. Okay, that one is really a pretty stone. You can definitely see the chondrals in there, and you see a good amount of metal.
And what's really cool about
Oh yeah.
rust on that one.
Yeah. Oh yeah, it shows
Oh,
way
yeah.
better.
Yeah.
It even has the regmaglyphs. Pretty nice.
Yep.
Wow.
Very nice.
Now, how about the inside on that one? Well, this is a nice one because it's a really almost white, light colored gray interior.
Mm.
Yeah, it's a beautiful meteorite.
Really nice.
At that angle, you can see the metal in it.
Yeah,
Yeah.
yeah.
Oh, yeah.
Try
And
not
then
to.
tell us what you did for the show and tell last week, please.
So for my show and tell last week, I played my upright bass or double bass, whichever you'd like to call it. I'm in a band called the Slow Rollers. We played this weekend and it was a lot of fun. A lot of people jitterbugging and stuff.
That is awesome.
So, yeah, and I've only been playing just a little over a year, so I've still got a lot to learn, but I have so much fun playing.
You had us all smiling. That's the key. So thank you.
Yeah.
You're a really good entertainer.
Mhm.
Yeah.
This is an LL3 that I got from Matt Stream.
Yep.
It was found in 2019. There you see the metal.
Yeah, you can still see the metal flakes in it.
Yeah,
Yeah, it
barely.
goes off nicely in the light.
The
Yeah.
cla-
Seeing some different class in it as
yeah,
well.
the clasts and the chondrals in this are so amazing. I can't do this meteorite justice. It is so much more beautiful in real life than it will ever be under a camera.
Much like me.
Yes, me. too.
Wow. Thank you so much, Allison. We really appreciate that. Some really beautiful meteorites. And we appreciate you sharing your talents with us last week.
Yeah, that was fun.
Let's see here. Ooh, double dipping here. We got Jules in the house. Jules, how are you?
Hello.
This is it's an LL6. It's NWA 5495. The reason I like it is it kind of has some angular-ish type class in it. And it's a little, the photo doesn't show it or the video, but it kind of blue and it's a bluish, has a bluish hue to it. And I just thought it was unique, being a LL6.
Yeah.
It is a very, very colorful LL6.
It
really
is
nice.
a super complex meteorite. Beautiful. It looks like it has like brecciation. It has all kinds of stuff going on in there. And we mentioned earlier that L chondrites are the most common. So this is an L6. That's pretty much. Oh, an LL6. Okay. The L6s are like the most common meteorite out there. So to have such beauty in a little slice like that, it's amazing.
It looks very mosaic.
It's a high. It's an S4, so it's a high shock value. So that must be where it's coming from.
Thank you, Cliff. That makes it a little more understandable why it's so fragmented like that, but still absolute gorgeous meteorite. Wow.
Absolutely.
That's cool.
Very nice.
Very nice.
So this is NWA 12520. It's a LL6 impact melt breccia.
Wow.
Oh, that's
There's
awesome.
the other
Certainly
side.
is. Oh,
The dual lithographies in there. Oh,
No.
yeah.
That would make a beautiful countertop.
This piece, I purchased two pieces just to see the varying class and whatnot in one particular meteorite. So I purchased a slice, which is this one. And then the very same meteorite, this little tiny little end piece. Same one.
Oh, wow.
Oh, that's nice. Yeah.
What a contrast.
Very nice.
Yeah,
Yeah.
but I
What's
liked
that-
it
what-
because of the contrast. So that's
What does
why
that weigh?
this one
That is
here,
Gorgeous.
66.45 grams.
Nice piece.
That's the back.
Oh, yeah.
Oh, that's gorgeous.
Oh, you're killing me.
Yeah.
Nice.
There's some meteorite pornography for you.
Yeah. Knocking it out of the park.
It's
That's
a really
is
low
gorgeous.
weathering grade too.
That's
Wow.
absolutely
All right.
stunning.
Oops, sorry. I do have one more if you want to see it. Oh, why?
Pretty metally for an L.
Oh, I
This
know what
is an
that is.
L. Yep, it's a L6 melt breccia.
Nice.
It's Las Ventios 262, purchased from Topher and cut by Chris Monk. Beautiful
Oh,
piece.
look at that.
A fair amount
Yeah.
of metal. in
Wow,
that
look at the
for
metal.
an L.
Yeah.
It's a nice one. I like the center that has a little bit of an angular clasp with the metal bleb in there.
Yeah.
Mm-hmm.
Wow. When you
Unique.
get it at the perfect angle, you can actually see the rivers of melt. There you go, Sue. The
Yeah,
rivers
it's
of
beautiful.
melt.
That's his
That's-
favorite phrase.
Yeah.
Rivers of melt.
Whoa.
Wow.
Let's
That is a
see.
beautiful, beautiful meteorite.
Yeah. I mean, I guess I see the rivers of melt in here.
Mhm.
It's
People
hard
tend to
to,
poo-poo L6s, but man, there's a lot
Yeah.
of variety in L6s.
there really is. There, and everything's so unique.
It's
And
another one of those classic Atacama weathering patterns too. You
Yeah.
got the metal's still there, but you can see the weathering along the cracks.
I was just
Ooh,
about to
that's
say, Cliff, this whole stone looked pretty much like yours weathered with the white lines and almost like pinkish hue to them.
Hmm.
Yeah,
Yeah,
that's
I really
gorgeous.
like this
That's
piece.
super piece.
Wow. Yeah. And for those out there on YouTube, this is not a very expensive meteorite. This is from the Atacama Desert in Chile, and there's a lot of it, not a lot, but there's a lot of this available. Yeah, and they're pulling out more and more pieces from the desert all the time. Wow, that was amazing.
Yeah.
Thank you so much. We are about to head into Meteorite 101 with Mike Kelly teaching us a little bit more about these LLs, and H's and how maybe they're even more related than we could think. So hold on one second, guys. Well, as promised, it's time for a deeper dive into the science of meteorites with Mike Kelly. Mike, take it away with Meteorites 101.
Evening, everybody. Yes, I wanted to talk about a group of meteorites called the transitionals. And these are chondrites that don't quite fit in the H, the L's, or the LLs. They actually sit in these odd spaces in between. So cover slide there. This is just a nice little interesting oriented one. This is Trissal, which was a 1927 fall. And it was just neat because they, besides being one of the transitionals, which there aren't all that many of, it's an oriented stone, and it had some interesting early science done on it as far as the flow patterns of how they were looking at atmospheric entry affecting shape. So it's got a little bit of everything going on there.
Yeah, very interesting, man.
Yeah. So again, like I said, these are transitionals. These are meteorites that are ordinary chondrites. So they're very similar to the H's, the L's, and the LLs, but they have characteristics that keep them from being put solidly into one of those groups. And so there's a lot of different characteristics of meteorites. And, in order to be one of these transitionals, you have to kind of break a couple of each of the rules in order to not fit into one of the groups. Otherwise, you would kind of be a L parentheses LL or an H parentheses L. And those parentheticals kind of mean you only have maybe one or two very minor things, and you're most likely in that outside group, and you're less likely in the inside group. But down in the middle of this slide, I got down all the different subtypes that there are. So there are subtypes in these transitional meteorites, all the way down to the 3.1 as far as unequilibrated chondrites go, and then they roll all the way up to the type 6s. There are no type 7s out there. And there aren't all that many of these. There's 56 of them in the category of HLs, and there's 129 of them in the categories of LLs. And out of that 170, 180 or so, you're looking at only 9 falls total.
Mike, I have a question because you hinted about it, but I need more of an explanation so I can understand it. You were talking about the H/L or the L/LL. How does that differ from a classification where it has H and then L in parentheses?
Certainly, yes. That's what I was saying. So if you have the vast majority of the characteristics of one of the groupings, and just like one characteristic of the other, then you would be a parenthetical, those ones with the parentheses on them.
Mm-hmm.
these ones are sitting where they're kind of a even blend where, you know, if you look at the fact that there's like 6 or 7 different things they look at when they're grouping these things into ordinary chondrite groups, you know, they're kind of split right down the middle. You know, they will have half the characteristics of an L and half the characteristics of an LL, even to the point where they might sit outside the oxygen isotopic ranges of the groupings. And I got one of the plots on there. We can look at it in a little bit there.
All right, thank you.
Right there. So as you can see, you know, when you plot out the oxygen isotopes, which is the upper diagram there, you can see that the H's, the L's, and the LLs all fall out separately. So they do, you know, represent different oxygen ratios that kind of say, hey, we're from a different parent body. You know, so one of the thinkings is that, and this is on the next slide, is that these transitional pieces, although they are very similar, so they might come from a region nearby where the H's, the L's, and the LLs come from, you know, they might actually be distinct parent body material. That's kind of splitting the gap as far as the, you know, the space within the solar system where these formed. And that's why they're transitional in their characteristic. But yeah, besides having oxygen isotopes that might be different from the usual HL and LL, they also have, if you plot the chromium content in camosite, these ones, you know, the H's, the L's, and the LLs all have a specific range of chromium content in their camosite. These ones sometimes will sit in an intermediate zone in between those brackets. So again, they took a lot of samples from H's, L's, and LLs, and then they analyzed them all. And they noticed that all this chromium content groups together oftentimes, but not in these transitionals. They'll sit in those dead zones in between. The other thing is we talked about magnetic susceptibility in the past as a method to looking at the different ordinary chondrites and determining which type they are. So just like with the chromium content, you know, everything kind of falls into groupings that'll be an H, an L, or an LL. And these also sit in a magnetic saturation value that is in between those different characteristics.
Yeah.
And then there's some other things that are interesting. The most recent paper out was looking at mean atomic weight. So if they completely digest the rock and look at the atomic weights and average it all out for all the constituents in there, this bottom graph actually shows you a logarithmic X plot versus the average mean mass of atomic weight there. And as you can see, the LLs and then the transitionals and then the L's and the HLs and the H's all plot kind of along a trend line, and they all sit in different group spaces. So again, that's kind of the newest way they're looking at it, going, okay, well, if you run that test, you can kind of see a breakdown and see how all these different transitional groups are valid, sitting between distinct LL, L, and H groups.
That is fantastic. I love that, how they all plot out there separately and distinctly.
Yeah. So, and I touched on this already a little bit, got ahead of myself. So why is this kind of important? Well, potentially it could tell you that these are from a separate parent body than their nearby formed HL and LL chondrite parent bodies. And even if that's not the case, basically what they show is they've undergone some formative processes on those parent bodies that have created some unique chemistries and compositions within these meteorites that have shifted kind of what we know as the norm of the groupings. So they're either pushing the boundaries and expanding them and showing that potentially there is a relationship among the H's, the L's, and the LLs on the same parent body, or like I said, you know, it's completely different parent bodies, and there's more of them out there than we've thought in the past.
Wow. Yeah, makes you wonder where it is actually. The truth lies out there somewhere. Just to be clear, so for everyone, the pictures that are being displayed in the background, these are not transitional meteorites. They're just beautiful meteorites to fill the void. So I don't want to cause any confusion.
Okay, so this slide is just a couple of the kind of interesting ones. And again, there are 180, 190 out there, so there's plenty to pick from. You know, they are kind of rare when you look at the fact that there's 76,000 meteorites or something like that in the Met Bowl right now. So they are a small percentage, but Bolide is kind of interesting, and I love that one because it went through ice and was recovered from underwater. So I thought that was pretty neat one. I also got Holbrook on the list there. Obviously, classic American fall, 1912. Still turns up stuff in the strewn field. Very well witnessed fall, very historic, very, very, very nice looking meteorites that come out of that strewn field. I threw Cali, which is from Colombia, down there just because that's one of the few that's a hammerstone. So that is a piece that hit a roof. And the first piece was recovered off the roof, so that's kind of interesting. And then I threw down Haxton because that's probably the most available out there besides probably Holbrook. And that had an interesting story because it was transitional, and then they looked at it and they kind of said, well, no, it's an L4, and it's stuck at L4 for a while. There was 2000 and 2006. It stayed reclassified as an L4. And then it popped back to being an HL4. So, they go back and they do more and more science on these things sometimes, and they change their mind.
Wow. Look at Portales Valley, people, please. Wow. Very interesting. I don't have any Haxton, but that seems like one of the witness ones that you should be able to get out there.
We have all 4 of those listed.
Oh, that's fantastic. We got some serious collectors. I have a few witnessed H's that I want to show off, kind of a speed round. If anyone else has something to show off, please raise your hand. All right, the first one I want to show off is Santa Filomena. So this fell in Brazil.
Oh, beautiful crust.
Yeah, this is a gorgeous, gorgeous specimen. It has some scuff marks on it.
Flow line.
What was the name of that again, Topher?
This is Santa Filomena.
Where's that from?
It fell in Brazil on 8/19/2020.
Very nice.
This is a 70-gram sample. This is not the stone that hit the roof, but here's a piece of the roof from, I believe, an adjacent house or on the ground. I'm not exactly sure. I'm not gonna make any wild claims, but this is a beautiful fresh one, and it is an H, a witnessed H with some nice little brecciation in there. And because it's an H, you're going to have a pretty good magnetic response to it. You can suspend the entire rock. So that's
So
an H.
Cool.
Topher, do you have a wicked sharp vein going through that piece?
You know, I think it may be a metal vein.
Metal
I
vein.
saw what you were looking at.
Yeah.
Just trying to see what was in the list. I can't read it.
Yeah, it may be a metal vein going through there. Yeah, this is what it actually looks like on the interior. If you were to cut that one open, you'll see that it does have a lot of metal inside.
Oh, yeah.
It's classified as an H5-6. So it has chondrule sizes that put it in the 5 and 6 range. So that's Santa Filomena from Brazil. This is Tomdoc. This is an H5. It was witnessed in Morocco in 2008, and I have a beautiful sample of it.
Oh,
you can, at the very top there, you can see the metal poking out. And it has tremendous fusion crust on it. But it has that same brown patches of fusion crust we're familiar with in nice witness falls. And again, a lot of magnetic pull on it, being an H.
And that,
So
that brown color, Topher, is an oxidation of the fusion crust as it's coming through the atmosphere.
That's our opinion.
Okay.
That it is a feature of the ablation process, not a terrestrial weathering process. Because this, like, even fresh ones that are picked up will have that. Here is my last H witnessed, and it's a beauty, guys. This is an
Buzzard
H4.
Cooley,
Oh, it's from Canada, eh?
Hey,
And best of all, it is an oriented one.
oh, that's killer.
They are absolutely gorgeous on the interior. You can see the H4, you can see the 4 of the chondrules right there.
Yeah.
And then,
Oh,
That's a pretty
Beautiful.
meteorite, man.
Yeah, beautiful, thick, stippled crust on that one too.
oh, yeah. Contraction cracks in there too. Yeah.
yeah,
Beautiful.
this one
That's a
has
pretty thick crust. That's like a pretty thick crust.
yeah, yeah. And buzzard coolies are just so beautiful on the inside that
Got a nice slice of it. I love them.
yeah, this one I don't think should hit the saw at all with that negative pressure bottom on it like that.
Oh, I wouldn't cut that at all.
Yeah, this. So those are my H class chondrites of witness variety. Yeah, that's kind of like my sweet spot. If Pat has a sweet spot of chondrule city, I'll claim the H's. Now, oh, Mike Kelly has something, and maybe I think it's going to go along with our 101, perhaps.
Certainly does.
Nice.
So this is NWA 487. This is the biggest transitional I have. It's a little over 4 gram piece. And this is an L/LL 3.2. So it is subtyped, and
Wow.
it's got lots of good looks to it.
Wow,
And
big on top.
That's very pretty.
yeah, so it's got a lot of very nice chondrules in there. And I had one because Pat was showing them too, and we were talking about the parentheticals. So that is NWA 10699. And this piece has a chondrule in it that's about 1 centimeter.
Oh, that's sweet.
that's the moon.
Did you mention the classification on that one?
This one is a LL parentheses L3.
Okay. Wow. That is pretty. It actually has a reflection on it, like a CR.
I like when the different light on it is really cool.
That's very
Shows
cool.
a number of armored chondrules there. And
Yeah.
interestingly, armored chondrules can be armored with metal or with troilite, and those appear to be troilite armored.
Fantastic. Thank you so much, Mike. I really appreciate that.
Yeah, no problem.
We are now switching to Marissa, show and tell. Hello, Marissa. What do you have for us today?
Hi guys, so I'm gonna share my screen because it is easier. So this is my little piece of Santa Filomena.
Ooh.
It looks a lot more shocked than mine.
Yeah, I was very pleased with that.
That's really cool, Marissa.
I love brecciation, so I like 3 of them I think fell in August in 2020. I think there were like 3 recovered witnessed falls, and seemed like the meteorites did everything they could to avoid my birthday. 3 of them in 1 month, and I was so mad.
Very cool.
Now, Santa Filomena has a shock value of 4, so you're going to find some shock pieces like hers out there.
Yeah, this is a 5.66 gram piece.
Very nice.
Shows a lot of detail for the size.
It still has the Brazil soil on it.
Yeah,
Yep,
that's really cool.
I was pretty happy with that piece.
Very nice.
Nice catch.
But, yep, that's what I've got.
Cool. Thank you so much, Marissa. Appreciate you checking in with us each and every week. Thank you. Our last show and tell of the night. Carl, how are you, man?
Hey, man, last week I shared something that wasn't a meteorite. I shared a Moog synthesizer, a rare model called a Minute Moog. And I've been a musician for years, so it was just something sitting in my studio. So it's kind of fun to show off something non-meteoritic for a change. I really like that. Okay, now we were talking about transitionals. This is Cynthiana from Kentucky. It fell in 1877. It's an L/LL4. And I'm just going to scroll through a couple close-ups of it we did with the microscope. I'm going to go kind of fast because there's a lot of them. In different polarizations.
Oh, yeah, it's got some,
And some image.
looks like green crystal.
Yeah, it's a really pretty meteorite, really in person, it looks prettier than it shows in a picture. But yeah, this is an L/LL4, so it's nice to have a witness transitional added to the mix.
Very nice.
Yeah, that's
Yeah.
cool.
I'll have a little fusion crust down in the corner.
Yep.
And for something that fell in 1877, I'm glad to have that.
Yeah, no doubt. Historic transitional witness fall.
Yep.
I'll take one.
I think we have 5 or
Right.
6 of the 9 known falls of transitionals.
That right there looks a lot like the new meteorite Al Hassan Ud Hamed 002.
Really, I haven't seen much pictures
Yeah,
of that. That's cool.
I'm about to release a video on YouTube about it, and it
Oh,
looks
nice.
a lot like that.
I look forward to seeing
I
that.
look forward to that. Yeah.
But the crystalliness on this left edge is really cool.
Yes.
Yeah.
Very interesting. Thank you very much for sharing that. That
Yeah,
is
you're welcome, Topher.
And before I sign off, I wanted to share because last week I shared with the group my some of my hockey equipment. I used to be a hockey goaltender for a team called the Stormtroopers, and I showed off my custom Kevlar mask, my glove and blocker. And we had a real good time. So maybe we'll do that again one of these times, guys. We are going to check in with Sue real quick with some announcements. Sue, what you got?
We have our theme coming up 2 weeks from now will be the second part of kind of what we did today. And that will be the other not so ordinary chondrites, which will include anstatites, rumarudis, type K, type G, those chondrites. And we're just doing a 2-part series this time. And my other announcement is guess who turns 51 tomorrow?
Woohoo!
Some old geezer.
Happy birthday.
Oh, jeez.
Happy birthday, Topher.
Happy
Oh,
birthday,
God.
old man.
Yeah. So I tried to end the damn thing without this getting in there. Yeah. Yeah. So tomorrow I'm officially very old. Today I'm just old.
Topher, are you gonna make the rule that you need to get a Martian that's the same number of grams as your age?
Oh, don't give him any ideas, Cliff.
I'm pretty close. When I go out to the mailbox after this hangout, there should be 45 grams of Martian knocklight.
Whoa.
Nice.
All right, guys. Thank you so much for joining us again on the Knowledge Bolide Hangout. We had a lot of fun and we learned a lot. Take care, everyone. See you next week. Bye-bye.
Bye.
Thanks, guys.
Happy birthday.